Hello. So in this video, we will be talking about the Pythagorean Theorem. Oh, what a nice little name. Um, so actually, before this, let's talk about what we talked about in the last video. So in the last video, we talked about triangle, base, height, hypotenuse, and also we talked about Jeez, that is a really bad triangle. In the last video, we also talked about finding theta, which is, in short, SOHCAHTOA. Guess what? We're still learning about triangles. I know. It sucks, but this is pretty important for um, trigonometry. And if you are going for a engineering degree in college, this will be very much important. So, Pythagorean theorem, what is it? So, Pythagorean theorem, we will draw ourselves a triangle once more. A right triangle. I forgot to specify that from the last video. If you see this square right here, that means that this whole thing right here is a right triangle. And what that basically means is one of the angles in that triangle will always be 90 degrees. Now that we got that covered, in a triangle, we will be given, for Pythagorean theorem, we will be given an A, a B, and a C. Now, it's almost the same thing as a square, where the length and the width doesn't really matter where it is. It can interchange. Like this could be length, this could be width, and so on. Almost the same for a triangle, where A could also be B, and B could also be A, but C cannot equal A or B. C will always equal C. Now, hopefully that made sense. Now, for the Pythagorean theorem, the equation goes like this. A squared plus B squared equals C squared. Now, what does that mean? Well, let's get an example. So say, for example, you're given a right triangle. That is one of the most perfect triangles I've ever made, by the way. And you are given 5 and 7. And you are trying to find the hypotenuse of this right triangle. So we're trying to find the hypotenuse. To do that, we will label these numbers as such. 5 could equal A, 7 could equal B, or 5 could equal B, 7 could equal A. It doesn't really matter. It will still have the same product. So, let's just say we'll go with this, right? So let's get our Pythagorean theorem equation, which is again a squared plus b squared equals c squared. Now we just plug these numbers in. We are trying to basically find c, which is the hypotenuse. So a squared is 7 squared plus b squared is 5 squared equals c squared. Now, just like back in algebra, you are trying to isolate whatever variable there is, which is c. C is already isolated, so it's fine. Now, just solve it. So 7 squared is 49, plus 5 squared is 25, equals c squared. Combine like terms, so 49 plus 25, that's 14. 4 plus 2 is 6, 74. Now we have 74 equals c squared. But wait, this doesn't look like c. It's c squared, but it's not c. We are trying to find c. So what do we do here? Well, what we do is we square root both sides. Now, when we square root both sides, you're canceling squared, which just leaves you with c. And that's what we want. So, let's take out my calculator. And now we will do square root of 74, and it is 8.6. The squared cancels out the squared, so it is just c. So our answer will be 8.6 equals c. Now, let's do another example. But instead of trying to find a hypotenuse, we're going to try to find one of the sides. So let us do this in red. So we're given a right triangle once more. Jeez, that was a really bad triangle. And the way that I spoke just was really bad. We're given a right triangle. Let's just say that's 90 degrees right there. This is a right triangle. Now, we're given 10, and the hypotenuse we're given 20. And now we're just trying to find one of the sides. Now just remember, this could be A, this could be B, but this can also be B, and this could also be A. Now let's just label them. Let's just say this is A, 10 is equal to B, C is equal to 20. Now we're trying to find A. Well, how do we do that? Well, just rewrite the Pythagorean Theorem. A squared plus B squared equals C squared. Now instead of filling out these two, we're filling out B squared and C squared, because that's the knowns that we have. The only unknown that we have is A squared, which is right here. So let's rewrite that. A squared plus 10 squared equals 20 squared. Now we square these two. So we get A squared plus 10 squared is 100. 20 squared is 400. Now, like I said, back in algebra, we want to isolate the unknown variable. We have 100 in this side, and we only have 400 on this side. In order to isolate A squared by itself, we will subtract 100 on both sides. That leaves us with A squared equals 300. Now, if we square root that, which cancels out this square right here, now we will do square root of 300. So now A is equal to 17.32. And that is your answer right there. Now I'm going to give you an example for you to do. You are given a right triangle that has 14 and 22. Try to find the hypotenuse using the Pythagorean theorem. You can pause this video to do this problem yourself. Alright. Now, let's solve it. I don't know why I'm erasing that. We can just move it. Right there. Okay. So we are trying to find the hypotenuse, which is C, which is an unknown. I will label 14 as B. I'm going to label 22 as A. Now let's do this together. 22 squared plus 14 squared equals C squared. 22 squared is 484. 14 squared is 196 equals C squared. Now just combine like terms. 484 plus 196 is going to be 10. 17 is going to be 18. It's 5, 6. So it is going to be 680 equals C squared. Square root both sides. That cancels out the square. So C is going to equal to 26.1. So our C will be 26.1. And that is how you use the Pythagorean theorem.